Not yet. Yeah, now it's okay.
Is it changing?
It's changing.
Very good. Thank you. Then now everything is set. Let's go.
Yeah.
So thank you, Dr. Bharat Bhushan. Thank you, Dr. Parveen Arora, Dr. Rashmi, Dr. Sanjay Singh from Agakar Institute, and my friend Karthik Bala, who took great effort in organizing this workshop, and all the participants who are here. So what I would like to present before you in summary is some aspects of the art of science communication. Okay, so let me proceed. Most of us, the moment we talk about writing science for non-specialists, that is non-scientific audience, that is people who are not engaged in science, or people who are not inside our discipline, we would think that the technical words are the main challenge. We will think that that is what is the key problem in communicating science. Science uses esoteric jargons, which in plain English would mean one thing, but within that particular discipline, maybe having a completely or radically different meaning, or a very restricted meaning. Okay. Like, of course, this is a part humor. Okay, so the girl is asking for 3 magical words. Perhaps one of the postdoc is replying: replication, transcription, and translation. Well, in our daily life, it means one thing. But whereas when you are going to talk about genetics, it means completely a different one, right? We are very restricted meaning. Sure, jargons are part of science. Rather, we don't call it jargon. We will call it as technical words. The journalist and public might call it as jargons. But are jargons really a problem? I mean, in our everyday life, we do talk about at least once in a year, whenever there is IPL, bowled, bumper, caught, no ball. What do you mean by no ball? No ball, does it mean that there is no ball? No, no one actually makes that kind of a stupid mistake, right? I mean, of course, if you're totally ignorant of cricket, maybe, yes. But as somebody said that in India, it's a religion, right? What is off leg? What is on leg? All of them are also technical words, right? So technical words are everywhere. It's not just in science. Some of you, if you learn cooking, you will know that there is a difference between tossing and stirring. If you are going to bake a cake, you need to fold the dough. But if you are going to make a puri, you have to knead a dough, right? Both are different. And anybody who knows cooking, and of course you have cooked these dishes, you will be aware of it. So technical words are not really the problem. Yeah, of course, if somebody is not familiar, they are not familiar. But it is not particularly a problem of science. That's what I wanted to show it to you, right? So it's not about technical words. And as Albert Einstein said, that if you can't explain it simply, you don't understand it well enough. Okay, keep it in mind. So if you can't explain your what you are doing without using the technical word as it is, I mean, suppose imagine that you have to explain to somebody who doesn't know cooking what is meaning of fold when you are creating the cake dough. Okay, when you put flour and egg and milk and all that, I mean, you are supposed to fold it, right? Now, what does it fold mean? You will be able to explain, right? It's a technical word, but still you will be able to explain. So in the same way, even in science, when we use technical words, they are explainable. So don't worry. That's not the main problem. Okay. Then somebody will say that, in science, the problem is accuracy. Scientists, we want to be very, very, very accurate. But general people won't understand it that well. Let's look at this question. Does Earth go around the sun or sun go around the Earth? I'm absolutely sure that in our younger classes, when we were in our elementary school, teacher, of course, taught us that Earth is going around the sun. Sun is standing at one place. Science textbook. I'm sure you're also going to say the same thing to maybe your younger cousin, your small cousin, if you have, right? But is it really true? What we know is that there is something called as a barycenter, which is the common center of gravity between two objects. Let's say, for example, if you take Jupiter and Sun, the barycenter is just outside the Sun. So both are orbiting that point. If you look at Earth, the barycenter of Earth-Sun system is about few centimeters away from the center of Sun. So Sun actually wobbles. It's not standing at the same place. But we don't say all this when you're talking to your elementary school child. And if you don't say it, the astronomers are not going to come and jump and say that, oh, you are communicating inaccurate stuff. Are they? Right? But is this the last word? If you know relativity, you will know that all these orbits are all stupidity. It's actually the planets are going in the straight line. But only thing is the space is curved. So it gives an appearance of being a circle or an ellipse. That's what you would say if you are going to look at it from the space-time perspective of relativity. Which one is accurate? Earth going around the sun? Earth and sun are orbiting around a common center of gravity, or the space-time curvature? So accuracy is a matter of context. Okay, accuracy is a matter of context. Depending on your audience, you become more accurate or more detailed. Otherwise, you give a general picture. But the general picture are not necessarily wrong, right? So that's something that we need to keep in mind. So again, if we take the words of Albert Einstein, everything should be made as simple as possible, but not simpler. That's the most important issue. So when you are talking about accuracy, it is simpler. The picture that Earth goes around sun is a simpler picture. I mean, it's a simple picture. I mean, I'm sorry. It's not a simpler picture. Okay. So it allows for people to learn. That is for people to understand things even better. More accurate picture, right? So even accuracy is not the key challenge in science. I mean, I'm talking about science communication, science writing, popularization. Technical words, accuracy, they are not the key challenges. They are challenged, but it's surmountable. We do surmount it in everyday life. When we talk about cricket to somebody who doesn't know cricket, we talk about cooking to somebody who doesn't know cooking. All these issues of accuracy and terminologies come in, and then we are handling it in our everyday life. So it's not the major challenge. What is the challenge? The challenge is the world of science is very, very different from our everyday experiential world. How is it different? Number one, in the world of science, there are new reality domains. I'm going to explain, don't worry. Okay, there are new reality domains. Sorry, one second. Second, the world of science is counterintuitive. It doesn't fit your intuition. The world of science, there is abstract, there is concrete. there is a constant back and forth relationship between abstract and concrete. The world of science is incongruous. And lastly, and certainly not the least, one of the most challenging aspects of science in terms of human emotion is organized skepticism. I'm going to explain all of them. So, new reality domain, counterintuitive, abstract and concrete, incongruous, organized skepticism. Well, my talk here is not to give you a lecture, but also to give you some skills, right? Because ultimately, after participating in this program, you are expected to write a popular account of the research that you are doing, right? So how does this come in? So if you write your first draft, mark all the places where you are talking about new reality domain. Mark all the places where your claims are counterintuitive. Wherever it is abstract and congruous, wherever it is incongruous. Let me come, when I explain, you will understand what it is, and then you'll be able to look at it. And this is going to be the challenge in communicating science to non-specialists. Okay. Let's look at, for example, new reality domains. What do we mean by new reality domains? There are new entities in science that we talk about, which we don't talk about in our everyday life. We don't encounter them in everyday life unless otherwise you are a scientist. Ionic bond, covalent bond. These are not something that you encounter in your daily life unless otherwise you are preparing for some competitive exam, right? Again, that is not in your everyday life experience, but that's for a specific act, right? So there are entities like this, metals, non-metals. These are all entities. Of course, we do encounter metal and non-metal in our everyday life, but the moment we see them, we don't see them in that fashion, right? When you see, for example, a vessel, you don't say that, oh, it's a metal. You say that it's a vessel. Your classificatory systems are completely different. So your vessel can be made out of mud. I mean, you may have a mud pot. It may be made out of metal. It may be made out of glass, but you call them as vessel because you are classifying it from the way you use it rather than the way it is made or the constituent, right? So there is a new reality domain in science. Okay. Then there are also in the new reality domain, processes are also completely different. Let's say, for example, transport. How does material go inside and out of cell? Okay. So we talk about passive transport. We talk about active transport. Okay. Certain things go by passive transport. Certain things have to go by active transport. Yeah. So there are multiple ways in which the transport occurs. Diffusion. Yeah. So many things. All these processes are not something that we again experience in our everyday life. What I mean is, in our conscious way, we don't experience. After all, you are a human being. You are made up of cell. Your every cell is experiencing it, but it's not your conscious experience. Another process, if you want to look, for example, fossilization. Okay. So fossilization is not something that, again, we experience in our everyday life, right? In our everyday experience. So there is a processes which are beyond us. A most important aspect of this new reality domain is justification. Let's assume that you stand up on a chair like this and then leave a ball and a feather at the same time. Quite obviously, the ball is going to touch the ground first, and the feather is going to float for a long time. If you are not familiar with physics, your explanation would be very simpler, right? Balls fall faster because they are heavier. Lighter objects float, heavier objects fall fast. But if you know physics, your justification completely changes. You say that both the ball and feather have to fall at the same rate, but the presence of air obstructs the feather air pressure, and that is why the feather is falling slower. So your justification has completely changed. You are now in the first everyday explanation, you are not answering why the feather is coming slow. You think that it is its nature to come slow. But the moment you take science, physics, now you say that the nature of feather is to fall as fast as in the same acceleration as a ball, but it is not, because something else is acting on it. So our framework of justification changes. Okay. So think about it. In many occasions in science, this is what is happening. Our justifications are, in some sense, one can say that the opposite of what you do it in your everyday life. We will examine this process more detail. So various entities like atoms, DNA, bonds, these are all new reality. These are not things that you encounter in everyday life. Processes, cell transport, DNA code, petrification. Okay, justification. You will say that not of you are not explaining why the ball is moving, but why the ball is stopping. Okay, in science, it's a very completely different aspect. Let's come to the other point that I talked about, counterintuitive. Well, suppose if I have a double slit and I have a beam of particles, okay, like this, a beam of particles like this, there are double slit. So what you expect is that if there is a screen, on the screen, the beam of particles should fall like this in two clusters, because particles can come through this or come through this. But what actually happens is you have a band, okay, right? You have a band, fringe. Yeah. Why this happens? Because of the quantum nature of particles. Particles behave both as a particle and a wave. So quite counterintuitive, something that you don't, let's say, experience in your everyday life, right? You're very counterintuitive things are happening. Yeah. Let's look at, for example, the evolution of eye. One of the major challenge in understanding. How did an eye evolve? I mean, as complex process as an eye, can it evolve by itself? Right? It's a big challenge. Even some of us would be flabbergasted. There was a philosopher who lived around 1850s in England. He coined the term called blind watchmaker. Okay, what does that mean? So what he said was, suppose you are walking in an island where no human being have gone ever. Okay, that was 1850s was the time that Europeans were going around the world, right? In their big ships. Yeah. So new places they were going. So quite obviously, many times they also went into islands which were inhabited, not inhabited. Okay. So he said that suppose imagine like that. And then you walk on the beach, and then your foot hits a rock. You will think that the rock was there always, or maybe it rolled from some other place and it has come there. You can give a very naturalistic explanation for it. But suppose if you're walking on that uninhabited island, and then you hit a watch, wristwatch. Most of you are young. I think many of you don't even use a wristwatch, right? It's our Zamana ka object. Okay, so I'll change his analogy to something else. Suppose you hit a mobile phone. Can you think that that mobile phone was there natural? Only should have come and left that mobile phone there. That's what was his question. The purpose of the question was, imagine lot of components, lot of structures arranged in a order, something like a mobile phone, unlike a rock, right? So can they evolve, or should there be some kind of a intelligent design, some kind of a creator shaping it, producing it? That was his challenge. But today we know in science, I mean, take it from me, I'm not saying that because I'm an authority or something like that. Even if it is very difficult to believe, those are some counterintuitive that things that we are talking about. So for you also, it will be very counterintuitive. Some of you who are not familiar with evolution or evolutionary sciences, we now have very clear evidence of how a complex mechanism evolved. Okay, there is a very interesting book called Insurmountable Mountain. Okay, there you can find a very easy account of how the evolution took place, evidences for it, and so on. It's very counterintuitive, no? That is why that 1850 that guy was completely flabbergasted when Darwin propounded his theory of evolution. This was around the same time. Remember that, right? Counterintuitiveness of science is very, very difficult for many people to stomach. Let's look at abstract and the concrete. Okay, there is you look at, for example, a hammer and a feather. In abstract, in physics, hammer and a feather are at the same rate, but in concrete, it does not. Okay, in our concrete experience, it does not. Unless and otherwise, you go to, for example, moon, where it's a vacuum or near vacuum. Okay, so our experience is bisected into abstract and concrete. And whenever we explain, we combine this abstract and concrete to explain a thing. Like, say, for example, if you're going to explain the falling of a hammer and a feather, we would use the abstract Newtonian physics and the concrete, that the thing that we observe that feather is falling slower and so on, to produce an explanation. So this abstract and concrete constantly come in our science. Same way with nature and nurture. Yes, our let's say characteristics. Okay, how much of it is gene and hereditary factor? How much of it is environmental variables? Physical appearance, personality characteristics, childhood experience, how we were raised, social relationship, surrounding culture. There is a abstract and the concrete, right? So in a level, at one level, genes are abstract, okay, and our everyday experience of how we were raised, etc., becomes concrete, right? So there is a combination of this is what we are, right? Let's come to the next point, which is incongruous. You look at physics, it's too abstract. You look at mathematics, it's too theoretical. You look at prehistory, it's too remote in time. Prehistory doesn't mean only history. It also means, for example, evolution. It also has meaning in geology, right? So in very many places, the prehistory comes into play, right? Yeah, so it's a remote in time. If you look at cosmology, it's a remote place, far away. Molecular biology, too small. Genetic therapy and things like that, inaccessible. It's not something that you can hold in your hand, right? So science in modern times is incongruous. It's not something we experience directly, okay? So it is away from our direct experience in our everyday life. Another unmediated experience. What I mean is unmediated experience. Okay, we do experience it through let's say microscope or other kinds of instrument, but they are all mediated experience, unmediated experience. I was talking about this skepticism. One of the important characteristic of modern science, And I also said that it's one of the biggest challenge, organized skepticism. Okay. This is what really puts off a lot of people, right? Let's do, like, for example, something like a vaccine trial, contemporary example. Yeah. So we do preclinical testing, then we do clinical testing, that also phase 1, phase 2, phase 3. Then after the vaccines are administered, there is a monitoring phase where we are monitoring what happens to people who are vaccinated. Is it still effective? Is it creating any after side effects, very rare kind of side effects, so on and so forth. What is happening here? Many people will think that, oh, you did a study on rat, so why don't we accept it? But we would say that, how do you know that what works in rat will work in human being? But then they will ask, then why did you do a study in rat? Right? So people think that by doing one study, you can get uncontested knowledge, indisputable knowledge. But as scientists, we know that what we get is pieces of evidences. And then we make inference out of those evidences, some kind of a tentative conclusions out of those evidences. And depending on the risk, we want lot more evidence to be convinced of something. And this is where the problem of organized skepticism comes in. There are many people who will tell me that why don't we follow so and so idea? After all, people have been following it for 1,000 years. But see, if the side effects are very rare, something like 1 in a million, like say, for example, the side effect of current vaccines are about 0.16 per million. That's what one of the early studies in India shows us. How will you capture it unless otherwise you do a study? Suppose if you have not done study, you will never be able to even capture that this is because of the vaccine or possibly because of the vaccine. So many drugs that we are taking, which we think people have been taking it for thousands of years, might really be having certain side effects of this range, something like a vaccine's side effect range. But we don't know because we have not done that kind of epidemiological studies at all. Okay, that's where the organized skepticism comes. So when somebody says that, oh, people have been taking, nothing has been happening, scientists would say that, but did you study? And that is where it picks people. People think that, what is this guy? He thinks that only they know everything. No, it's not about we know everything. We know that our human knowledge is fallible. It's not because the arrogance is not because we think that we know. The arrogance is because we think that we can be easily fooled. Okay, so we need to keep check on what we believe. That's where the organized skepticism. And this is a very big challenge because most of our daily life, we accept things and move on, right? But in science, we don't. We question everything. That's the nature of science that we saw. So maybe I'll just go back, refresh those 5 points because they are important to keep in mind. New reality domain, counterintuitiveness, abstract and concrete, incongruous, organized skepticism. So as I was pointing out that when you are writing, if you can color code this in your writing, you will know what you need to do. So what do we need to do? These are problems. But science is not only about problems. Science is about finding ways of solving it, right? So how do we do it? There are 3 golden rules in science communication. The 3 golden rules are from known to unknown. You start from what people know and lead them towards the unknown. Second, from simple to complex. You provide a simple picture and then add factors, components, and make it complex and give a picture of complexity. then from particular to general. In science, we do the opposite. We have general and then derive the particular, right? So we say angiosperm, and rose is an example of angiosperm. But whereas in real life, you need to say the other way around. There is rose, which gives flowers. There is jasmine, which is also flowering. We call all of them as angiosperms. So it has to be put in the other way around. Okay. So these are the three rules: from known to unknown, simple to complex, from particular to general. The particular to general is not really, I mean, if you look from purely scientific point of view, generalizing from some particulars is not admissible. It's not logical. But for our understanding, that is how we understand. Okay, the public people's understanding works that way. So we use it for communication, not for justification. So for this, what we do is, how do you make unfamiliar familiar? There are 4 tools that you have. What do you mean by tools? Suppose if you are a electrician, you will have a screwdriver, you will have a plier, and so on, right? Similarly, when we are a science writer or science communicator, it is not only applicable for print media, but it's also applicable for any kind of media. We have 4 tools. What are those 4 tools? The tools are analogy, Imagestick, illustrations are example. Here, when what I mean by illustration is not drawing picture. It's about example from some real life thing that we would have seen in our experience. Okay, and thought experiments. These are the 4 tools. Let me explain each of them by giving you few examples. So from that you will be able to get an idea. Let's take, for example, analogy. So I want to explain how a protein is cooked inside a cell. So I start with the analogy of cooking. So there is a recipe book on the shelf, like the genome is inside the nucleus. You want to cook some dish, you open it, you flip it, you go to the right page, you take a small bit of paper, on that you write, because you cannot take that whole book to your kitchen. So you make a note, jot down in a small bit of paper, and that's what is mRNA, messenger RNA. So you keep it, the recipe on a counter, and then basically counter here means a kitchen table. I mean, you have a, let's say, oven, you have a stove, you have whatever that you need for cooking, right? That's what is ribosome. Ribosome is the kitchen. Then you need ingredients, right? So if you want to cook a cake, you need eggs, you need sugar, you need flour. So if you want to cook a protein, you need different kinds of amino acids. But then you can't put flour, sugar, and eggs in any proportions. You have to put it in a right proportion, right? So they have to be measured and then properly are put in. In the same way, you can't just throw in all amino acids. It won't work. They have to be joined one by one in the right order. That's what tRNAs do. And that's what, for example, your measuring jar does. You measure a particular amount of flour. You say that you take 1 cup of flour, then you need a 1/4 cup of sugar, and so on and so forth, right? So if you put it in right proportion and you take care of your process, you get a good cake. In the same way, inside our cell, proteins are produced. So basically, we are using analogy. Cooking, something that we know, something that we have seen, something that we can understand from our experience. I am linking unfamiliar. That is how a protein is made inside the cell through this analogy. Analogy is also used in other places. Like, for example, you want to explain a very simple thing of refraction of light when it goes from one medium to another. Something that, again, you would have experienced if you are riding a cycle. But of course, here I have put a car, but many of us would have experienced it in a cycle, particularly if you're coming from rural area. So you ride the cycle on a metal road, tar road, and suddenly, suppose, let's say there is a patch of mud. When your cycle enters that muddy patch, your cycle will turn. Okay. In the same way, you can say that the light that enters from one medium to another turns. Refraction analogy, right? You want to explain you can use our everyday experience of a pump, pipe, water, yeah, let's say a turbine, okay, a valve. You can use it to explain some amount of circuitry, right? So these are all analogies. Okay. Let's come to the second tool, which is Imagestick. In the Imagestick, we create an image. You can imagine the pathogens as enemies, the immune system as our security forces. So in the security forces, you have border police, you have army, you have local police, you have special police, you have intelligence service. Same way, the immune system has many components: T cell, B cell, blah blah blah, and so on and so forth. Right? So basically, you are using the concept of defense, security, to explain the idea of immunity system. All of us in our school as would have read this, right? I mean, a leaf as a factory. Leaf is a factory which produces glucose using sunlight, water, and carbon dioxide or air as raw material. Product produces glucose. Base material is carbon dioxide. I'm sorry, oxygen, and so on and so forth, right? So essentially, you are using a Imagestick idea of a factory to explain photosynthesis in a right. So same way, when you are talking about the predator prey relationship, okay, how when numbers increase, numbers decrease, things change. Okay, these are all something that you can use Imagestick to explain. Real world example, that is illustrations and so on that I was talking about. Okay. Suppose I want to find the distance of a stellar object, let's say a nearby stellar object. I can't take a measure tape and then go to that stellar object and measure it, right? So how did we measure it? Today, you might say that you will send a radio wave. Well, that's not really possible because some nearest star is some few light years away, which means that it is going to take few years, at least 5 years for the light to reach there and another 5 years for it to come back, total 10 years. That is not going to work. So how do we find that it is actually that far away, at least in a range? We use a method called parallax method. You can do this experiment yourself. Hold a pencil, keep your hand straight, close your right eye, close your left eye alternatively. So you will see that as if the pencil has moved in the background image. Okay. So this is called as parallax shift. So basically, when the Earth is going around the sun, you observe the particular star or star cluster and then find out what is in the background. And after 6 months, when Earth is here, observe. So this is like one eye and this is like your other eye, right eye, left eye. So you will find that the objects are not same. So from this parallax shift, you can know what is the distance. That's how we find the distance. So I'm using a real life example, something that I can do, you can do, you experience, I have experience, to explain a scientific idea of how people find or how astronomers find distance of stellar objects. Okay, so this is how it will look like. So when I'm in two different places, the background stars are like this. So at one time the object will appear here, the other time the object appears here. No, I mean in this. So that tells you how much shift has taken place. From that you can calculate the d. Okay, so the idea, right? Let's go to the last one, last tool, thought experiment. So what does this thought experiment do? The thought experiment is an experiment where you imagine the experiment, you don't actually perform. So let's imagine the experiment. Suppose there is a lift, okay? That lift is at rest. The person is standing on the ground. Let's assume the cable that is connecting gets a cut. So the lift will start falling down, right? Lift is now in what is called as free fall, which means it's just falling down. Now imagine a question. Suppose from my pocket, a pen comes out. I am inside the lift. The pen is also inside the lift. It has come out of my pocket. While the lift is falling down, will the pen touch the ground? If it is at rest, if the pen comes out of my pocket, it will fall down. No question, clear. But while in free fall, will it fall? It won't fall because Newton's law. I will be accelerating, the object will be accelerating, both will be accelerating at the same rate. So we both will appear to float. Okay. So this is what happens in a free fall. If I have a weighing machine, let's say at the bottom of the lift, I have a weighing machine. Okay, I have a weighing machine. When I am rest, it will show my weight. But when it is in free fall, even if my legs are on top of this weighing machine will show 0. That is basically, we will become weightless when we are falling. And that is the reason people float inside the satellites. I mean, not satellites, space stations. Okay, because space station is constantly falling toward the Earth. It's not that there is no gravity. If there was no gravity in the space station, then how can the gravity impact moon, which is even further away from Earth? Okay, it's not like, for example, the walls of the spacecraft will prevent the gravity from going inside. We know that such things don't happen, right? So what we think in our everyday life as an example, I mean, explanation that there is no gravity in a space station, that is why people float, is wrong. There is gravity in a space station, and it is because of gravity that we are floating. Because the gravity is pulling me and the spacecraft both at the same rate. So relatively, we don't move. Myself and the spacecraft doesn't move. So I appear to be floating. Okay, so that's what is happening. Yeah, so these are all thought experiments through which you explain. Let's take another thought experiment called as Hillbird's hotel paradox. Okay, let's assume this Hillbird hotel has infinite room. Okay, not 1 room, 2 room, 10 room, 100 room. It has infinite number of rooms. And it is a tourist season, so it's fully booked. There are people, no vacancy. But suppose a new person comes. Can you accommodate that person? Yes, you can accommodate person. What do? You ask the people from room number 1 to go to 2, from 2 to 3, 3 to 4, 4 to 5. They will all, when they move, the room number 1 will become vacant. You can give it to this person. Something that in childhood we read as infinity plus 1 is infinity. Yeah. Through this thought experiment, we explore a very esoteric concept called infinity. But things doesn't stop here. This is very simple. Let's assume this hotel. This change is very simple. Okay, let's assume that now infinite people are coming. Already there is infinite rooms and all rooms are filled. Now infinite number of people have come. Can you give them space? This is where the complexity comes. 1 plus infinity, 10 plus infinity, complexity is not there. Here is the confinity. So there are infinite number of people, new people who want room. All the rooms, infinite rooms are filled. What will happen? Even now you can accommodate. Very simple. You ask everybody to multiply the room number by 2 and move to that room. Which means people who are in room number 1 will move to room number 2. People who are in room number 6 will move to room number 12. People who are in room number n will move to room number 2n. So which essentially means all room numbers which are odd, that is 1, 3, 5, etc. will become vacant. Infinite odd numbers, you can fit in infinite people. So basically a concept like esoteric concept like infinity plus infinity is infinity. Why? We get an understanding from this kind of a thought experiment. Okay. Well, when we talked about tools, I spoke about 4 tools. There is a 5th tool, which is a very important tool, humor. Humor is permitted. Quite here you can say, right? Still single, always. Yeah, humor is permitted. Don't think the humor is not permitted. Now, how do you tell your story? Okay. So I'm going to take a few minutes on explaining how do you tell your story. Stories have 3 acts. A beginning, a middle, and a end. Okay. So beginning, I mean, let's assume that we are telling a simple story of Noah's Ark. Okay. So the Noah sees that there is a flood, huge rain is coming. It's going to be deluge very soon. Okay. So he says that the change is coming. We must prepare. And he starts preparing the boat. Everybody laughs at it. Beginning. Middle. Actually, the rain happens. He takes various species on board. Okay. Because of the huge rain, there is it's not a plain sailing. There is a trouble. Okay. Heavy rain creates tension. But then Noah stick to the plan. Okay. Says that, okay, let's sail toward the promised land. He sails the end. Okay. That's how usually a story is constructed. There are 3 acts. Of course, more complex stories are there, 5 act, 8 act, and all that. A very simplest story is generally a 3 act structure. I'm sure you have seen this ad, right, for the biscuit. Yeah. Do you recall this advertisement? So the advertisement starts with, for example, the old man cleaning the bottles. Okay. And then the camera turns and then you see her. So you understand that this is a father and she is the daughter. Okay, they don't say it, but subtly you understand. So some kids come by. Happens that old man goes out and she is womaning the shop. Okay, so small kids come, they don't. One kid gives a origami to her and she gives biscuit. And then the last scene is that all kids are coming with the origami toy and then taking biscuits, right? So 3 act. A story is told. A simple story is told. Okay. So whenever you are writing, this is one option available to you, which is like you tell a story. There is a 3 act. Okay. So you think about it, you tell a story. Alternatively, if you have looked at this advertisement, you can do it right after my lecture. Also, you can go and look both of these are ad in YouTube. You will understand what I'm saying, right? Okay. This structure is called a spectacle. So in the spectacle, there is no story, but beautiful images which creates emotion. Okay, various kinds of emotion, happiness, sadness, whatever. Okay, so various kinds of emotion, they are there. So whenever you are communicating, you have only two options. Of course, the third option is boring, not communication, no use. But if you are communicating only in two ways. Either you are telling a story or you are creating a spectacle. Okay, so in the spectacle, you will talk about the spectacular facts. Okay, spectacular aspects. So you can construct your write-up in either of these two ways or a combination of these two ways. One part is a story, one part is a spectacle. I mean, you can combine like that. So these are the only two ways that we have, and these are the way we do. So in a story, it's like a climbing mountain. So there is a background, then there is a rising action, then there is a climax, and there is a falling action, there is a resolution. So if you're talking about some scientific discovery, there is a background to that discovery, meaning that there was something that we know, there was a knowledge gap. Because of that knowledge gap, we were confused whether this is this or that. That's a climax. Then how do we know that this or this? Then somebody comes up with a very ingenious idea. Why don't I do this experiment? Why don't I do this observation? Why don't I do this study? Then that study is done. The matter is resolved. The result that you know that this is true or that is true. So you have a structure. There is a story structure. Okay. So in science also, you can bring in a story structure of pre-climax, climax, and anticlimax. Okay. Beginning, climax, and anticlimax, like this. Here, of course, in this chart, they are talking about 5 act. I told you that we also 5 act, right? So background, rising action, climax, falling action, and resolution. But in that ad, there was only 3: background, climax, and resolution, because ad is very short, right? So there is only 3 structure. In a film, for example, there can be even 8 act structures and so on and so forth, right? Yeah. So what is your mission? Your mission is to either create a story or a spectacle, but with a difference. What is the difference? When people read what you have written, they should have a bulb in their head, meaning that they should not only have some emotion, but there's some tickling of their brain. They should feel that, oh, I understood something. I realized something that I was not aware of till now. Okay, so that's one important aspect. Second, you should be able to take your audience from known to unknown. And third, you should be able to take your audience from simple. I mean, you have to present your ideas simple, but not simpler. Okay, so these are your mission when you are going to communicate your story to ordinary people, public, and so on as part of this AWSAR mission. Why do we need to communicate? As I pointed out earlier, as Einstein pointed out, that if you cannot explain it to in a simple fashion, it means that you have not understood it properly. Well, maybe you will be able to write jargons. You'll be able to write some paragraph for your paper, but really you don't have understanding. That's what Einstein pointed out. So how do you go about actually writing? Imagine that you have a brother or sister who is about 12 years or 13 years or 14 years, okay, and you want to tell what you are doing to that person. Or assume that you have a grandma and you want to explain to your grandma what you are doing. Okay, so how do you do? Where will you start? You will give a background why you took that research. Then you will say that what was the challenge that that was there and that was emerging from that background. Okay, some knowledge gap, some thing that you wanted to find out, something that was a challenge. Okay, so that knowledge gap. Then how your research either aided in bridging that gap or at least made a progress. Many times we may not be doing earth-shaking work, right? But every step counts, right? So that every step counts kind of statement. This is how a story works out. Okay, so you can use all these tools that I talked about. be aware of the specific nature of the science, which is world of science, which is different from world of our everyday experience, the everyday experience of your grandma or your imagined brother, sister. If they are there, it's fine. Otherwise, okay, or imagined audience. That's how we go about doing it. Okay. With this, I'll stop. There are some questions and so on in the chat. Maybe I'll get into that. Thank you.
Sir.
Karthi, vanakkam.
Yeah, Karthik.
No, sorry, it was an accident. Please go ahead. Sorry.
Okay.
It's okay.
So first, I will request Karthik to ask some questions.
Okay, there are some questions here. I'll take it. In which language do I write a story? Language, any language, right?
Well, it's primarily for English and Hindi.
So it has to be either in English or Hindi for this AWSAR competition. So that is said. We can use technical terms. If it is common, of course, you can use technical term. If not, you explain what the technical term mean actually. Okay, that's what is important. Okay, the weightage in that is all. I think rules of AWSAR that we won't go. Can we include a pictorial block diagram of research methodology in the story? So that's another question that you will have to think about when you are writing your story for AWSAR. I'm not talking about for your paper publication. What is key in your story? Do you want to present your research methodology as the key point, or is it your findings as a key point? I'll explain it. This is a very important point when you are talking about public communication. Making this distinction is very important. Okay, I did a story on a satellite which was launched by NASA to study water vapor in atmosphere. Okay, so they put a satellite in. I mean, basically, it was not water vapor. But basically, it's because there are micro comets which fall on Earth. Almost 400 comets fall every day on Earth. Okay, so they wanted to do a count on it, because this is linked to the question of how water came to Earth. So there is a theory that water came to Earth from comets. Okay, constant bombardment of comets brought water. So they want to estimate and all that. So when a comet falls on upper atmosphere, assume that I'm looking outside, from outside Earth, I'm looking toward the Earth, then the water will become vapor. Okay, what? Your voice is muted. You are okay. So it will become water vapor. So if you use your infrared camera, you will see a black patch when it becomes water vapor, from which you can count. But the black patch can also happen because of electronics. So how do you know that the black patch is real or electronic artifact? So what they did is very simple. They put two infrared cameras. So if you compare the images, if at the same place you have the black patch, then you know that it is water vapor and not electronic, because two systems cannot fail at the same time. Here they are talking about the methodology. The results are not important. Results are some vague thing like itna water come, you can tell the story the other way around. The other way around is you don't talk about the methodology, but you say that what you got as a result. The study found out that so much amount of water is coming. And if this is how the water has come on Earth, then it should have taken so many years. So is the theory that water came to Earth from comet right or wrong? Do we have enough evidence to justify it or not? Sorry, 1 second, just hold on.
If you have any query, please raise your hand. We will take your questions one by one, or you can write on the chat box also.
Yeah. So you can also tell the story that way. So it is not necessary. You in your research paper, you will write everything, your methodology and results. But when you are writing a popular communication, It is not necessary that you have to write both. Okay, you can choose one. You can choose one angle. Okay, depending on which is your best foot, right? So that take a look. Okay, that's fine. I'm doing PhD in maths. No, in the popular articles, we don't give references. Okay, popular articles, you don't give references. I mean, if you want some idea of how to write a popular book, popular science article, I'll suggest you two places, or rather 2-3 places. One is look at, for example, New York Times. I mean, these are all Googleable. New York Times science articles, or Washington Post science articles, or there is some one magazine called as Quanta magazine. Quanta magazine. You just Google it, you will get it. So you will find articles here on really esoteric topics too, like mathematics or quantum physics and so on. So you can take a look at that and then get an idea of how you can go about doing it. You can use photos in your articles.
Sir.
Okay. The research story must be related to the research that you are doing. Okay. Good.
Sir.
Yeah, I think that's fine.
Sorry.
Thank you.
Yeah. So I replied the general queries in the chat box itself. There are some specific queries. I think you should explain.
Yeah, I read it and then I answered it.
Okay. So
about writing mathematics, popular mathematics. Yeah. So about writing popular mathematics, I told you you can look at two places to get an idea of how it is done. One is that Quanta magazine. Then there is another place called as Symmetry magazine. Symmetry magazine. Okay. So just Google Symmetry magazine. You will get, like Quanta magazine, you will get. Okay, so there you will find some samples of popular mathematics articles on recent work. I'm not talking about some ancient work. Okay, so that will give you some ideas. Yeah.
Okay, Jagruti. Yeah.
Hello.
Yeah.
Yeah. Hi, Jagruti. Please.
Yes, sir. Thank you for the wonderful lecture, sir. Sir, actually, I have completed my PhD in nanotechnology in 2019. And yeah, presently I'm working as a freelancer in science writing.
Okay.
Yeah, related to articles, manuscripts, and review articles, sort of work I'm doing. But I'm more interested in working in this area, like as per your lecture, the lecture we have heard now. So I'm more interested in working in doing this kind of work. So this is a very good platform actually. But apart from such workshops, are there any internships or jobs where we can full-time work as a science communicator? This is what I wanted to ask.
About training, Venkateswaran, we might be announcing some training programs which are, let's say, a few weeks to few months in due course. Soon we are going to announce. One, we are going to do a week-long one in October along with the National Chemical Laboratory of Pune. Okay.
Okay. Yeah.
So keep looking at our website. I mean, these things will come to know because we will be putting it up in our website and also, of course, circulating things in social media.
Okay. So, and one more thing I would like to ask, as I think 2 to 3 workshops are done in science communication, right? So can we get some contacts or some students who are already working in this field, so that at least we can combinedly we can work with them and we can get to learn more about this field?
Yeah, sure, why not?
Yeah. So yeah, because I am in Pune only and I'm very much interested in working in this field, but I'm not getting the ways, like how should I get into this? So even
where do you work, or where do you do in Pune?
So I'm working as a freelancer.
Okay, I have DM'd you. Just reply to that. Okay.
Sure. Yes. Thank you so much, sir.
So there are some queries related to submissions also. How do we submit the article? What are the guidelines? And what criteria we used to take or we used to consider for evaluating the articles? So myself and my colleague Dr. Gaurav Jain will be explaining the technical technicality of submission of article. So this is the website of AWSAR. It's spelled like AWSAR-DST.in. So one query was there where we can get the last year stories, awarded stories. So you can have these stories in the publication section also. Here is the book of the AWSAR awarded stories in 2019. Here is the book of 2018. These two are AWSAR awarded stories for 18 and 19. For recent year, like in the 2020, so it is there in results section, and you can view the articles. These are the AWSAR awarded articles of 2020, and we are compiling these articles in a book format with ISBN, and its copy editing is being done. So soon it will be uploaded on the website also. And regarding award category and all things, which has been explained well. And like for guidelines, there are few guidelines, standard guidelines. The articles we are inviting, it is from the research being pursued by the researcher. It should not be a general article. And the word limit for submission is 10,000 to 1,500 words. And we do the plagiarism check also, and accordingly marks will be evaluated. Each article will be evaluated by two experts. One expert will be evaluating the technical aspect, and another expert will be evaluating the popular standards, popular science writing standards. So these are the standards of submission guidelines. And one question was there, considering the what jury consider for evaluation. We consider 4 aspects: language, what is the content, what is the format, presentation, and overall how article looks like a popular science article or not. So I will now request my colleague Dr. Gaurav Jain to present about the submission of article and how you can register.
Yeah, thank you, Bharatji. Am I audible?
हाँ जी.
Let me share my screen first.
अभी कर पा रहे हैं आप स्क्रीन?
Yeah. Is it visible?
हाँ.
Okay, so this is the AWSAR website, awsar-gst.in. Like selection criteria and other guidelines, already Bharatji told all these things. I will show you this login process, login and sign up process. So here you will find on the top right corner, there is a link called login. So if you have not signed up, so you can click here, and if you have already signed up, so you can click on sign in. So I have already created one account. Let me. Okay. So once you sign up, then you log in from here. Yeah. You will find this submit your story link. Then you click here. It will ask some basic questions like, have you earlier submit your story? If you press yes, then it will automatically come out, because in AWSAR you can no, it is for award. If you press yes, it will ask the reference number and title of the story, and it will also ask if you are awardee. If you press no, then only you can enter inside the form. Like you click on submit your story. it will ask all these questions. So I'll press no and click on submit your story. So basically this is the form, story submission form. So you have to enter all these details. This time we have added this upload Aadhaar card to validate that the person is entering the right. So here you will enter your PhD details, supervisor details, and this is where you can enter your category, subject category. And in this area, you will upload your doc file. This is the area you can where you can upload your doc file. You can also preview and submit your story, or you can save. For you can enter all the details, and later you can upload your story. So you can save all the other details, and later when you finish your story, you can upload it from here. Okay, so any question related to submission and website? Sir.
Thank you, Gauraji. A few queries which I can see in the chat box. So I will take it one by one. Some person is in 6th year of PhD and age is 35. So there is no age limit for that. And if the candidate is still in the registered period of their PhD, they can apply for AWSAR. Well, if somebody has completed his or her PhD, so he is not eligible for AWSAR award. Either he or she should be PhD or in postdoctoral category. There is no age, there is no page limit, but word limit is there. So 1000 to 1500 words are only required. Shri, you have any query? You have raised your hand. Shri.
Good morning, sir. Am I audible?
Yeah.
Namaste, sir. So just wanted to ask that since I had also submitted the story last year, so there is an option while submitting that whether we had previously submitted the story. Or since I'm not awarded, so should I mark as yes or and move on, provide the reference number, or should I just say a no?
So you need to provide the reference number. Am I right, Gauraji?
GG.
You need to write your reference number,
and then it will ask you whether it is awarded or not. Then there you can press no. Then you can submit your story.
Yes, sir. So if I'm changing the format of my story, then even then I need to give my reference number, right? If I'm changing the title, if I'm changing the way of writing.
So yeah, if you have ever applied in AWSAR award, you need to give us the reference number.
This is only for taking record. So how many resubmission are there? So you can entirely change your story, which you have already submitted last year or previous year. You can change your content. You can change your title. So that's entirely depending on your wish.
Thank you so much, sir. Thank you.
Jagriti.
Sir, I'm not doing postdoc. I have completed PhD, so it means I'm not eligible to apply.
No, you are not.
Okay, thank you.
Swaleha, please.
Yes, hello.
Hello. Yeah.
I had submitted a story in 2019, but I clearly remember that by mistake, I was outside the deadline period. I got a reference number by email, but unfortunately, I cannot find that number right now. So what should I do?
So you write to us on connect.awsar@gmail.com with your credentials. Or you can re-register yourself. You will get the fresh reference number also.
No, but there is an option that says that provide previous reference. So should I say not submitted because I cannot find the reference number?
Yes, you can write to us.
Okay.
Connect.avsar. I have written the chat box also.
Yes, sir. Yeah, I found.
Connect.avsar@gmail.com.
Okay, sir. Thank you.
Sarita Maurya asked, I'm a PhD scholar in 4th year. Yeah, you are eligible. If somebody has completed his or her PhD, they are not eligible for AWSAR award. This is exclusively for PhD scholars and postdoctoral fellows. For PhD category, you should be in the 2nd year of your PhD. In the 1st year of PhD, generally literature review is being done. So you have not started your research actually. So 2nd year onward, you will be eligible to apply for the AWSAR award. Rashmi ma'am. We don't require any published paper for your story. This is not mandatory. There is no age limit for that. There is no age limit for submission of article. Yeah, 2nd year of PhD is only eligible to apply. Yeah, Dipankar, please. Dipankar.
Very good afternoon, sir.
Good afternoon.
Yes, sir. Sir, one thing I want to clear from you. Actually, due to this pandemic, for about 1.5 years, we have been not allowed to the lab. So my materials was in that laboratory. What I started the work. Now I am completing my work, and within a month or two, I will communicate it into journal. But in my story to our sir, I am writing that material. Shall I write just material? Try to give the complete. That question arises because my work is not published yet. We are trying to publish it. So what shall I do?
So there
It
is
is a
no
biomaterial.
mandatory. There we have not kept mandatory as if you should have a paper published. So you can write your story based on your research. We do not ask for publication.
Sir, actually not, sir. I am not asking for publication, but the material I want to involve in my story is it is not yet been published. So what shall I do? If I said that exact material name, so before publication it will be disclosed.
Okay, TV sir. TV sir. So this question.
Yeah. Tell me.
Yeah, this question usually people ask regarding if we give the material name or end product name, and which require patenting and all, which they don't want to disclose. How to present?
So see how it is handled in media. How it is handled in media. For example, recently there was a paper from some set of scientists on a material which is a kind of a super glue, okay, which is useful, which can stick and unstick by electric shock. So what they have written is it's a polymer. They did not write the exact name of the material, because the exact name of the material is not going to matter for you and me. Okay, they wrote that it is a complex polymer. Maybe they also said that it contains a particular chemical, that's all, which was extracted from mussels. I mean the sea organisms, right? Okay, seashells basically, right? So you don't need to exactly mention the specific material that is in your paper, your patent. Popular article, that's not required, right?
Okay, sir. Okay, sir. Thank you, sir.
Thank you. So we have query from Facebook also. It's live streaming live. 6th year of PhD, can they apply? Yeah, they can apply.
Yeah, one more question from
Yeah.
Nick.
Yes.
He's working as a RA at NIV Pune. Is he eligible to write?
So he or she can write in postdoctoral category.
Yes. You can write, Nitin.
Yeah, Pala, more question from your side. You have mobilized your team.
What only remarks I'm like our students are enjoying the session. That's what messages I got, like thanks message for
So
they really enjoyed the. So we can expect from our institute many stories for this year program.
From your institute, we got 28 registration for this.
Yeah. Okay.
A number of images. Any limit for number of images, TV sir?
No. See, about 2-3 images are fine. More than that, it won't make any sense.
Sir, I have one small query.
Sir, please.
About that book, story book, sir, 1819, which was compiled. So, what about the availability? Where it is available? Means it is in ebook or something?
It's a printed book also. It's available with us. That actually government guidelines says that printing should be done in limited quantity.
Okay.
So, but it's available on our website. You need only the email address, and you can download the PDF book.
Okay.
In the publication section of the
Yes.
website, it's there. All the lectures, previous lectures, this year lectures will be available on the YouTube page of AWSAR, and it's being live telecasted on Facebook also.
Great, sir. Very, very interesting and very informative sessions, really.
When I'm checking that Facebook questions, if somebody has submitted article earlier in previously also, and yeah, they can modify the article and resubmit. They can modify. So, TV sir, shall we ask to close the day? Fine. Yeah, Bala, Karthik.
Yes.
Yeah, any input? Yeah, or otherwise formally we will close this session.
Yes. I think there is no more questions. I'm checking Facebook also, so there is no questions, and we can formally close the session. And thanks to TVV, Bharat Bhushan, and NCSTC and Vigyan Prashar, ERI for supporting this wonderful activity.
By the way, I want to add one thing. Karthik Bala is also a good science writer. He writes in Tamil, and it comes in some of the leading Tamil newspapers. And he is also a good communicator in the sense that complex ideas in a very interesting way. Some of the recent research, and I think people in ARCA should also catch him and eat his head. So why only FUD to be? You also should have FUD, Karthik. Okay.
So now Karthik will be the resource person for workshop at ARI.
Definitely, happy to do that.
We are expecting at least more than 100 stories from ARI.
Yeah. We will follow it up with all our students, and we'll submit as many as possible.
Yeah. So thank you everyone.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.
Bye.
Thank you.